Welcome to Unit 2, Lesson 12, Writing and Graphing Systems of Linear Equations. Our learning goal for this lesson is to recall what it means to solve a system of linear equations and how to do it by graphing. We have 3 learning targets for this lesson. Learning target number 1, I can explain what we mean by the solution to a system of linear equations and can explain how the solution is represented graphically. Learning target number 2, I can explain what we mean when we refer to 2 equations as a system of equations. And learning target number 3, I can use tables and graphs to solve systems of equations. For glossary terms, we have solution to a system of equations, a coordinate pair that makes both equations in the system true. On the graph shown of the equations in a system, the solution is the point where the graphs intersect. Our next glossary term, equivalent equations. Equations that have the exact same solutions are equivalent equations. Our first practice problem says, the knitting club sold 40 scarves and hats at a winter festival and made $700 from the sales. They charged $18 for each scarf and $14 for each hat. If S represents the number of scarves sold and H represents the number of hats sold, which system of equations represents the constraints in this situation? So as we start learning about these systems of equations, I want to show you what they represent with words and with the numbers and variables. So the first equation we would have, we know that there are 40 scarves and hats. So that means if we add scarves plus hats, it's going to equal 40 total. They tell us that S represents the number of scarves and H represents the number of hats sold. So that means we're going to have S plus H equals 40. And the only place we see that is right here on C. Next, we know that they made $700 from sales. We know it was $18 for each scarf and $14 for each hat. So the way we would write that is the amount per scarf times number of scarves plus amount per hat times number of hats, and that is going to equal total made. So we're saying if we take the amount that was charged per scarf and multiply it times the number of scarves, that will give us the amount of money that was charged for scarves total. Then if we take the amount per hat times the number of hats, that is going to give us the total for hats. Then if we add the total amount of money made off of scarves and the total amount of money made off of hats, that is going to equal the overall total from the sales. So we know the amount per scarf is $18. We know that scarves are represented by S. We know the amount charged per hat is 14, and we know that H represents the number of hats. And this is going to equal the total amount made, which we know is $700. And we see that on A, and we see that on C. So the only choice that has them both correct is choice C. Choice A only has one of the correct equations. Choice B has neither of the correct equations. And choice D has neither of the correct equations. If you have any questions about how to solve this practice problem, please use class time to ask for further clarification so that you are prepared as we move forward. Our next practice problem states, here are two equations. Equation 1, 6x plus 4y equals 34. Equation 2, 5x minus 2y equals 15. Number 1, decide whether each xy pair is a solution to one equation, both equations, or neither of the equations. So what we're going to do is substitute the first number in for x and the second number in for y. So for A, we have 6 times 3 plus 4 times 4 equals 34. 6 times 3 is 18. 4 times 4 is 16. 18 plus 16 is 34. That is true, so it does solve the first equation. Then we have 5 times 3 minus 2 times 4 equals 15. 5 times 3 is 15. Negative 2 times 4 is negative 8. 15 minus 8 equals 7. 7 does not equal 15, so it solves the first, but not the second. Now let's look at B. We have 6 times 4 plus 4 times 2.5 equals 34. 6 times 4 is 24. 4 times 2.5 is 10. 24 plus 10 equals 34. 34 does equal 34, so it does solve equation 1. Now we try equation 2. 5 times 4 minus 2 times 2.5 equals 15. 5 times 4 is 20. Negative 2 times 2.5 is negative 5. $20 minus 5 equals 15. 15 does equal 15, so it solves both of them, so it is a solution. For 1C, now we have 6 times 5 plus 4 times 5 equals 34. 6 times 5 is 30. 4 times 5 is 20. 30 plus 20 is 50. And 50 does not equal 34, so it does not solve the first equation. Next, we have 5 times 5 plus 2 times 5 equals 15. 5 times 5 is 25. Negative 2 times 5 is negative 10. $25 minus 10 equals 15. 15 does equal 15, so number 1C does not solve equation 1, but it does solve equation 2. And finally, D. We have 6 times 3 plus 4 times 2 needs to equal 34. 6 times 3 is 18. 4 times 2 is 8. 18 plus 8 is 26. 26 does not equal 34, so D does not solve equation 1. Next, we have 5 times 3 minus 2 times 2 equals 15. 5 times 3 is 15. Negative 2 times 2 is negative 4. And 15 minus 4 equals 11. And 11 does not equal 15. So D does not solve equation 1 or equation 2. Number 2. Is it possible to have more than one pair that is a solution to both equations? Explain or show your reasoning. The answer is only if the equations are equivalent. If not, they will cross once, or they are parallel and never cross. So we are graphing straight lines. These are linear equations. If the lines are equivalent, then they will have the exact same answers and they will be the exact same line. So they will have an infinite number of solutions. If they are not equivalent, then there are only two choices. Either the lines are parallel, they will never cross, and there is no solution to the system of linear equations, or we just have two random lines and they will cross each other one time and have one solution. If you have any questions about how to solve this practice problem, please use class time to ask for further clarification so that you are prepared as we move forward. Our next practice problem says, explain or show that the point 5, negative 4 is a solution to this system of equations. The first equation is 3x minus 2y equals 23. The second equation is 2x plus y equals 6. If this point is a solution to the system of equations, then when we substitute 5 in for x and negative 4 in for y, both equations will be true statements. So for the first equation, we have 3 times x, so we substitute in 5, minus 2 times y, so we substitute negative 4, and that should equal 23. 3 times 5 is 15. Negative 2 times negative 4 is positive 8, and that should equal 23. 15 plus 8 is 23, and 23 does equal 23, so it makes the first equation true. Now we need to check the second equation. We have 2 times x, which we're going to substitute in 5, plus y, which we're going to substitute in negative 4, and that should equal 6. 2 times 5 is 10. If we add negative 4, that is the same as subtracting 4, and that should equal 6. 10 minus 4 is 6, and 6 does equal 6. Because it makes both equations true, this is a solution to this system of equations. If you have any questions about how to solve this practice problem, please ask for clarification so that you are prepared as we move forward. Our last practice problem for lesson 12. Diego is thinking of two positive numbers. He says if we triple the first number and double the second number, the sum is 34. Number 1, write an equation that represents this clue. Then find two possible pairs of numbers Diego could be thinking of. So, if we triple the first number, so that would be 3x, and double the second number, that would be 2y. The sum means plus, and the sum is 34. That means it equals 34. Then find two possible pairs of numbers Diego could be thinking of. So first, let's try if we let x be 0, then this becomes 2y equals 34. You divide both sides by 2, and y equals 17. So when x is 0, y is 17. Now, let's try it when y is 0. 3x plus 2 times 0 equals 34. 3x equals 34. Divide both sides by 3. And we get x equals 11 and 1/3. So we go down to where y is 0. We go over until 11 and 1/3. and we can put a second point. Now we can draw a straight line between them. Next, Diego then says, if we take half of the first number and double the second, the sum is 14. So 1/2 x plus 2y equals 14. First, we let x be 0. And we get 2y equals 14. We divide both sides by 2. That gets rid of it on the left. And we get y equals 7. So when x equals 0, y equals 7. Next, we're going to let y equal 0. 1/2 x plus 2 times 0 equals 14. 1/2 x equals 14. We are going to multiply both sides by 2. 2 times 1/2 is 1. So we have x equals 28. So when y is 0, x equals 28. And now we can draw our line here. Now number 3. What are Diego's two numbers? Explain or show how you know. A coordinate plane is given here in case it's helpful. So what we're looking for is the point where these two lines cross. And that looks to be approximately here. So it looks like the number could be 8, 5. But I'm going to test it. So we would try 3 times 8 plus 2 times 5, and that should equal 34. 3 times 8 is 24. 2 times 5 is 10. 24 plus 10 is 34. 34 does equal 34, so that does make the first equation true. Now let's test it in the second one. We had 1/2 times 8 plus 2 times 5 equals 14. 1/2 times 8 is 4. 2 times 5 is 10. 4 plus 10 equals 14. And 14 does equal 14. So this is in fact the number that, or the pair of numbers that Diego was thinking of. He was thinking of 8 and 5. If you have any questions about how to solve any of these practice problems for Lesson 12, please use class time to ask for further clarification so that you are prepared for success as we move forward to the next lesson.